Hello students, welcome back to Turito's live classes. How are you all doing? I hope you are having great time. So students, we have entered in this new session of the chapter called as what? Is matter around us pure? Now let's quickly recap or revise whatever the topics which we have covered during last sem sessions. So what we have started with? We started with some classification of what? Matter, okay? Then we discuss about physical and chemical classification of matter. We understood all the properties of pure substances, right? Followed by the properties of elements and compounds, correct? In the last class, we talked about mixtures. So basically, what are these new terms? Quickly tell me what we know about these new terms. Yes? Yes, so many of you are typing that, ma'am, it's a chemical classification of matter. That's very correct. So we know that matter is divided into two categories chemically, or this chemical classification is based on chemical properties. Now, which property here we have talked about? Of course, we talked about, or this classification is majorly based on the chemical composition. Let me write it here. Chemical composition, or I can say on the basis of purity. We have classified matter into two ways, into two categories, such as pure substances, correct? So this is what is classification of matter. First is the pure substance, and second what? We are having mixtures. What we are having? We are having mixtures or also impure substances, right? So pure substances are further classified in two ways, in two subcategories, which are nothing but what? Elements and compounds. Elements and what? Compounds. Then we have learned about the classification of mixtures also. We have seen that mixture is classified into two categories, homogeneous and what? Heterogeneous. Okay, homogeneous and heterogeneous mixture. So that was all about the chemical classification of matter, which we have covered in our last two classes. Okay. So students, I want you all to go through all the properties, all the definition, all the examples of these different types of matter. Some of them are elements, some of them are pure compounds, many of them are mixtures, right? So it is very important, and just maintain your notes so that you can go through it quickly whenever you want to, before your exam or for your daily studies also. All right. So now moving ahead. Then after that was a quick revision of the topics which we have covered. Now what are we going to do, what are going to learn in today's topic, in today's session? So we are going to understand some differences between mixtures and compounds. Okay. So in last class we have seen there are some differences between compounds and elements. Though they are pure substances, but they are having some differences, right? So here also we are having what? Mixtures and compounds. They are completely different from each other. So now we are going to understand what are the main differences between these two types of matter. Then we are going to start a new concept called as solution. Okay. Followed by we are going to study about what types of solution. Okay, is that all clear? Like, this is how our class is going to look like. Okay. Now before jumping into the class directly, okay, the knowledge which we have gained from our previous session, I think we need to apply that knowledge to solve some questions for our better practice. So what is true about homogeneous mixture? Student, we have seen that whenever we are having combination of two or more substances all together in a random combination ratio, it is not fixed combination ratio, in a random combination ratio we get mixture, correct? And this mixture is categorized into homogeneous and heterogeneous mixture. So now what are the properties of homogeneous mixture? Try to understand, try to recall those properties and give the proper answer, the correct answer for this question. So your options are: homogeneous mixture is the mixture of two or more than two components. Second is, in homogeneous mixture the composition and properties are uniform throughout the mixture. Option C is both A and B are true, and D is none of the above. Okay, I am giving you examples such as what we are having: water, okay, and you are going to add some sugar crystal or salt crystal, and on stirring what you are going to observe, after some time the sugar particles or crystals are well dissolved, they are uniformly dissolved. This is looking like what? Homogeneous mixture, correct? So I am not able to see any boundaries between sugar crystals and water molecules, correct? So that's why I can say it is a homogeneous mixture, be it a salt solution, be it sugar solution. These are few examples of homogeneous mixture. So based on that, I think, I am very sure that homogeneous mixture is the mixture of two or more than two components. Yes, it can be, right? It's a mixture, and we have seen its definition. It's a combination of two or more substances altogether in a random ratio. That's why A is right. So next is, in homogeneous mixture the composition and properties are uniform throughout the mixture. See, if this is what is the beaker, and if I am asking you to take out 1 tablespoon of one of this solution from the upper surface, and I am asking you to take some solution out from the bottom of this beaker and test it. So what do you think? Are these two samples are going to test same? Of course, yes. That's why we say, like, the properties are going to remain throughout the chemical composition when we talk about homogeneous mixture. Okay. So yes, now we are close to our answer, which is what? Option C. Okay, this is what is the correct answer, that both A and B are true. I hope you all are able to get it. Moving ahead. Which of the following properties does not describe a compound? So here they are asking us to revise the properties of compound. So for option A is, it is composed of two or more elements. Second is, it is a pure substance. Okay, just a minute. It is they are asking does not describe a compound. Okay, so emphasize on that word, does not. Okay, it cannot be separated into constituents by physical means. It is mixed in any proportion by mass. So yes, here are some properties of compounds which we already have discussed. Quickly, your answer has to be what? D. Students, whenever we have studied about compounds, we know that compounds are pure substances, be it water, be it HCl, NaOH, NaCl. So these are some compounds. Okay, they are made up of two or more than two substances, correct, but in a fixed ratio. They have fixed ratio, they are chemically combined, and it's not possible by us to separate these constituents by any physical means, correct. So based on this, this is what is a property of compound. Even B is property of compound. All of these are properties of compounds. But they are asking that which of the following properties does not describe a compound. So compound is mixed in any proportion by mass? No. It's not a mixture, it's a compound, and that is what is an identity of a compound, that they are having fixed combination ratio. That's why this becomes your answer. All right. Next question. Blood and seawater are examples of what? These are the both mixtures, both are compounds. Blood is a mixture whereas seawater is compound. Blood is a compound and seawater is mixture. What do you think? We have seen these examples in one of the concepts. What do you think? Quickly. Either mixture or compound, or both are the mixtures, or both are the compounds. Yes, your answer is right. Both are mixtures. Correct? So basically they are made up of so many things altogether. Let's take example of blood. So blood is made up of, blood has water, blood has plasma, blood has different blood cells, correct? So it is a mixture, it's a homogeneous one mixture, right? And here like next is what, seawater, made up of salt, some minerals, some water, okay, so many substances all together, and this is nothing but a mixture, correct? Okay. Next question is that two substances A and B were made to react to a reaction. Okay, that means substance A and B are reacting with each other, and a third substance is getting formed, that is what, A to B. Okay, according to the following, they have given this chemical reaction as well. Okay, so that means A is reacting with B to give you product, that is what, A to B. So which of the following statements concerning this? So now students try to understand, this is very simple though it looks like very big. Here we are having A, which is the one of the reactants. Okay, this is A is reacting with B to give you A to B. Chemical reaction had happened. We have revised whenever this happens. We know this is what, these are like left hand side is what, reactants, and right hand side is all about products. So try to understand. See, option A says that the product A to B shows the properties of substance A and B. Okay, the product will always have fixed composition. Product is this. The product so formed cannot be classified as compound. Product so formed cannot be classified as compound. The product so formed is an element. So we need to understand like what is right in case of product. Option A says that product A to B shows the properties of substances A and B. Do you really think so? We have seen whenever a compound gets formed, okay, actually two or more constituents are going to react with each other chemically, and it is going to give you a compound, a chemical compound, a brand new substance which has its own set of property, correct? That means the properties of A to B are completely different than the properties of A and B individually. Or okay, so this is what is very important property which we have discussed. So the product A to B shows the properties of substance A and B becomes your, now this we don't observe this whenever compound forms, right? Moving ahead, we are having second option, the product will always have a fixed composition. Yes, we have given one example of what, suppose we are having hydrogen reacting with oxygen giving you what, water, and water remains the same, I mean the chemical formula is definite. So yes, it is right. The product so formed cannot be classified as compound. Why not? This is what is a compound. Okay, so we have, let's suppose we have obtained A to B, and with its definite chemical formula, it has its own set of properties. It is your compound. Okay, so it is wrong. The product so formed is an element. Is it element? A is an element, B is an element. When these two different elements are reacting chemically with each other, they are going to give you a compound and definitely not an element. That's why this is also wrong to talk about the properties of compound. So we are having the correct option which is talking or which is concerning about product is what, option B. So the product has its own fixed chemical composition. Okay, this is what property of compound. I hope you all are able to get it. We are just revising the topics which we have covered from the last session. Okay, that was all about it, student. So now it's time to jump into our today's session. Okay, so our topic is what, differences between mixture and compounds. After understanding the definition, different properties and different examples, we need to study, or it is a better way to study these two different types of matter together. We are going to understand their what can we say, like it's better to compare these two substances altogether for our better understanding. So here we are provided with mixtures and we are having compounds. Okay. So a mixture can be separated into its constituents by the physical processes. Okay, the first point which is going to differentiate between mixtures and compounds is that they can, like their constituent can get separated by physical processes. Now what are those physical processes? Such as what? Filtration, we are having evaporation, we are having sublimation, distillation, solvent, like a magnet, solvent extraction and magnetic separation. So basically these are some separation technique which we can do physically. Okay, we are going to learn about all these techniques one by one in detail. But point here is that the components or the constituents of mixtures can get separated by any physical means. In contrary, what happens in compounds? A compound cannot be separated into its constituents by physical process. We need proper chemical process to separate the constituent of any compound. Okay. So we have taken example of what table salt, sodium chloride. If I am taking, if I am writing it here, NaCl, sodium chloride. If you are asking me, like ma'am, separate sodium and chlorine from NaCl, is it possible for us by sitting at our home and opening the jar of salt and take out the sodium and chlorine? No. We need electrochemical process or with the help of electrolysis. With the help of what? I'll write the word here once again for you all. With the help of electrolysis, that means electricity is going to break down the substance, that too in its molten form. Sodium chloride, it's a salt, it's a solid, right? So we need to melt it, that is what we call brine solution, and then when there is we are going to pass the electricity throughout that solution so that there will be separation of these constituents, and it has its own chemistry, detailed chemistry, electrochemistry. We are going to learn about it in our higher grades, but as of now try to understand we cannot separate constituents of compounds very easily. We need proper chemical processes. Followed? Let's move ahead. Elements or compounds just mix together to form mixture. Yeah, that is what is the definition. And no new compound is formed. Yes. So students, we have taken example of, let me give an example of iron fillings and sulfur powder. Okay. If we are going to take these two substances, these two elements in a bowl, in a container, and we are just asking them to stay together. We are not doing any chemical change. So it is a kind of a mixture because these two elements are not chemically binded with each other. So they are forming a mixture. What are they doing? They are forming a mixture basically. So it is not wrong to say that there is no formation of any new substance. So that is the physical state of components may change, but chemical composition will remain the same. Exactly. If the substances, the elements, the molecules are just staying together, maybe there are chances that they will change their physical state, but the chemical composition or the chemical properties which these substances are having is not going to change, because we don't see any chemical change happening when it comes to mixtures. Okay. But if you are going to heat up this the same mixture, iron and sulfur all together in a test tube, we have seen we are getting new substance FeS, which has its own set of properties, okay, which are different, which are altogether different from iron and sulfur. Correct? So that is your compound. When they are going to get combined chemically, there will be some change, and that's how we are having a formation of compound. Okay. Let's try to understand compounds. Elements react to form new compounds. Elements react to form new compound. Let's stick to sodium chloride only. sodium and chlorine reacting together, giving you sodium chloride. What had happened? These two elements are reacting with each other to give you what? Sodium chloride, which is a compound. Correct? The chemical change, composition is changed after reaction. So what does it mean? That the chemical composition of that substance had been changed. Okay. Again, iron and sulfur, when we heated them up, we got a new substance which is a compound. Okay, and that's why we say chemical change had happened, and this had give us what? A new substance, a brand new substance which is a compound. Okay. If you want to make a note of this, you can quickly. Okay, let's move ahead. So point number 3, property number 3 in mixtures, what it is? A mixture shows the properties of its constituents. Yes, what do we observe in mixtures? When they are going to combine with each other physically, that means they are just staying together. Okay, so actually there is no change in their identity. Maybe their color is going to remain the same, maybe their size going to remain the same, but there is no remarkable change in their what? Identities, in their properties. Whereas when we study about compounds, the properties of a compound are entirely different from those of constituents. Remember the example of what? Water formation. We are having hydrogen, we are having oxygen. These two elements are getting combined to give you H2O. It is what? Water. This is a liquid. These two are gases. Remember, we discussed about this property in compounds in detail. So, water helps to extinguish the fire, but what is the property of hydrogen? Hydrogen individually, it burns out, it is combustible. It combusts with what? A pop sound. It burns with a pop sound. What about oxygen? Oxygen supports the process combustion, and property of water is completely reverse. It is helping, it helps to extinguish the water. So that's why we say the properties of compound are entirely different. They are completely different from those of its constituents. These are constituents of water. Water has a new set of properties. Okay. Next, the composition of a mixture is variable. A mixture does not have a definite formula. Yes, let's suppose we want to make what? Salt solution, like sugar solution, or let me give you a proper example. If I want to make lemonade, okay. So maybe there is one student in the class who likes that lemonade to very sweet. So if he is making lemonade, he is going to add that extra tablespoon of sugar, correct? And suppose I like salt. I like salty. The taste which of that lemonade I like salty. So what I'm going to add 1 extra tablespoon of salt. Maybe there is the other student who likes it sour, right? So he is going to add, he is going to squeeze extra drops of what? Lemon. So 3 people are making the same thing in a different ratio, any random ratio. That's why we say it's a mixture and not a compound. But when we are going to, 3 of us, if 3 of us are going to bring the sample of water from our respective homes, what are we going to observe? Water has a chemical, definite chemical formula, which is not H2O2, which is not H3O4. It is only H2O. Okay. So that is what is the difference between mixtures and compounds. Followed? That's why we say compounds has what? A definite formula. Got it? Is there doubt? Is there any confusion? Moving ahead, we are having mixtures. Point number 5, property number 5. Mixture does not have a fixed melting point, whereas compounds are having what? Sharp melting or boiling point, because the number of atoms or the molecules or elements are fixed. Okay. And here the combination ratio is itself is not fixed. So definitely they can, if it is made up of, a mixture is made up of more than 2 substances altogether in any random ratio, definitely all of these are having their individual property, they are having their own melting point. Altogether the melting point of the mixture is going to be vary, okay, mixture to mixture. This is not the case in compounds, okay. So each and every compound has a sharp melting point or sharp boiling point, all right. Is there any doubt? Are we all clear with this so far? Okay. Moving ahead, students, now we have entered in the next concept of our chapter, and again which is very, very important, such as what? Solution. So what do you mean by solution is? Let's try to understand. It is a homogeneous mixture of two or more substances. It is a homogeneous mixture of two or more substances which do not react chemically is known as what? Solution. It is a homogeneous mixture, two or more substances which are not going to react with each other chemically. It is what known as what? Solution. Let's try to understand this with the help of some example. Okay, focus here. This is what is I can say some little amount of any, let's suppose I am writing here as a sugar, okay, just imagine. So this is what? A crystal of sugar. Let's suppose this is what is crystal. There are some crystals of sugar which we have taken, 2 or 3 tablespoons of sugar. Now you have taken water. I am writing here what? Water. Now this sugar is being added in this water, correct? So how your beaker will look like? Okay, so this sugar is like the sugar particles, the sugars are sugar crystals are going to get what? Dissolve. They are going to get dissolve in what? Water, and it is going to give you solution. It is going to give you solution. Now student, try to focus here. Solution has two components. It has two components. How this solution is getting prepared? With the help of substance called as what? Solvent. It's a big word, solvent. And we are having what? Solute, small word, solute, solute, correct? So here if I am asking that what is a solvent? Solvent is the substance in which something is getting added in minor quantity, in less quantity. So here we are having water which is acting as a what? Solvent. To form a solution we need two components. We need solvent and solute. Solvent always it is in measure quantity. Okay, solvent is a substance or it is a a chemical substance in which something is getting added. That something is nothing but your solute. In this case we have taken sugar. Let's try to understand. Your sugar crystal is nothing but what? Solute, which is the second component of solution. Okay, so let's revise this. The composition of solution can be varied. Okay, we'll understand after this point afterwards. Try to understand the components of solution. How solution is getting prepared with the help of solute and solvent. With the help of solute and solvent. Example what? Sugar is getting added in what? Water. So what are we adding? We are adding solute. We are adding solute, which is lesser in quantity. I will write it here, which is minor in quantity. Okay, and solvent is what? Water. All together they are going to give you what? Sugar solution. Okay, these are some example: iodine in alcohol, soda, water, air, soda water. Okay, so this is what is a solution. Air is also kind of homogeneous mixture. Okay, so this is nothing but solution. In chemistry we are going to understand like there is a big chapter for which is based on solution, but as of now we need to understand like what is a solution, how solution looks like, how solution gets formed. So students, try to understand solution gets formed because of first component what? Solvent. Okay, because of binary solution system. Binary, bi stands for two. Bi is what? Two phase or two substances are getting involved. So binary solution has two components. First is what? Solvent. First component is what? Solvent. Now what we have to say about solvent? the component which dissolves in other component. Okay, so it helps to dissolve what? Solute, right? Solvent usually present in larger quantity. Try to understand, whenever we prepare a solution, always try to understand solvent is in bigger or it's in larger quantity. Next component is what? Solute. The component which dissolves in the solvent. The component which dissolves in the solvent is what? Solute. So solute usually present in lesser quantity. Solute is always present in the lesser quantity. So focus here, this is what is an example of the same formation of solution. So we have taken some salt, okay, this is in a bowl, we have taken some salt, and we have taken some water, correct. So water is large in quantity, When we dissolve this salt in water, okay, when we dissolve this salt in water, we have obtained what? I will write here, salt solution. This is what is a salt solution. So quickly tell me, which one is solvent, which one is solute here? Yes, the component which is larger in quantity becomes what? A solvent, okay, and the component which is what? Lesser in quantity becomes your solute, correct? Is there any doubt, is there any confusion? So these particles of salt or crystal of salt are getting what? Dissolved completely. This is what? Your homogeneous mixture, okay. So homogeneous mixtures are also called as what? Solutions. We learn about this property. So how can we say it's homogeneous? If you are going to take some solution out from this layer, and if you are going to take some solution from this bottom layer, top and bottom, definitely the test is going to remain the same no matter from where you are taking that solution out and testing it, okay. Also there are no visible boundaries, right? I cannot differentiate, okay, this part is what? Of salt and below it's sugar, water. No, salt and water, they have dissolved with each other in such a way that we are able to see no boundaries when we are observing the solution, and that's why we say it's a homogeneous mixture. What do we say? What do we call it as? It's a homogeneous mixture. Have you all followed till here? Is there any doubt? Is there any problem? Anyone? Students? Quickly make a note of this. Components of solution, solvent and solute. Write down the definition and draw the diagram also quickly. So we have started with solution, okay. So this is what, these are some examples: sugar and water, salt in water, iodine in alcohol, soda water, air. These are few examples. This is what is a definition. It's a homogeneous mixture of two or more substances which do not react chemically, is known as what? Solution. Yes, here we see salt and water are just getting dissolved with each other. They are not there is no chemical reaction is involved, okay. There is no chemical change is happening here. That's why we say they are not chemically combined. All right, quickly make a note of this. Yes, so we have a second example, what? Sugar in water. The same, we have taken sugar particles or sugar crystals, and we are having water which is also known as what? Solvent, which is also measure in quantity, whereas sugar is what? Lesser in quantity. It's lesser in quantity, and that's why we say it's a solute, correct. Sugar and water both are going to get mixed, they are going to get dissolved to give you homogeneous mixture, which is nothing but what? A solution, okay. Shall we move ahead? All right. So now next point is that types of solution. Students, we are moving towards the next concept. After learning all about solutions, it's time to understand what types of solutions we have in chemistry, okay. So there are different types of solutions which we are going to learn, okay. First one is what? Based on the solvent used. Okay, students, just now we have seen solution has two components, right? I'll write it here. What first is solvent, which is measure in quantity, okay, and we have next component which is what, solute, which is lesser in quantity. Okay, this solvent can be any substance, likewise this solute can be any substance. Okay, so if the solvent is what, water, if we are using solvent, water as a solvent, it has a special name. When we are using water as a solvent and then we are adding solute to this water, it is going to give you a solution. It has a proper name, and that name is nothing but aqueous solution. What did I say? I repeat. Whenever we are using water as a solvent and adding some solute into it, okay, they are getting dissolved well, so that we have obtained a solution. This is how we have obtained solution, but this solution has a specific term, which is what, aqueous solution. Aqueous is derived from the word aqua, and aqua is nothing but related to what, water. So basically we are saying that we have used water as a solvent to prepare solution. Okay, followed? This is what aqueous solution, focus here. So this is water, this is some solute, they are getting dissolved with each other and we have used water. Correct? This is aqueous solution. This is what? Aqueous solution. Just a minute. Yeah. So try to understand, most of the substances are soluble in water. In our universe, in this earth, there are so many substances, and almost like all or most of them can what, dissolve in water, and that is the reason we are saying water is a what, universal solvent. Water is a what, universal solvent, and this is what is the reason. It has the capacity to dissolve almost all the substances into it. Okay, so that to give aqueous solution. So water is a universal solvent. Example what, salt in water. Okay, next moving ahead, students, if we are having water as a solvent and almost most of the substances are getting dissolved in water, it is going to give you solution which is nothing but aqueous solution. But what if I am using the other solvent which is not water, can you imagine the name of that solution? It is non-aqueous solution. Earlier we learned about aqueous solution where we use water as a solvent. Now we are not using water as a solvent or any other chemical, the further liquids we are using. Okay, and that's why we say it's non-aqueous solution. Just have a look, these you must have seen such diagrams or images where we have seen these colored substances. These are chemicals which are getting dissolved. These are solutions which are having solvent other than water, and that's why the word non-aqueous solution. Alright, so let's quickly revise it. All the substances don't dissolve in water. Okay, sometimes we don't need water to get dissolved. All the substances, because substance has no tendency to dissolve in water. Okay, so therefore the other solvents such as benzene, okay, we are having alcohol, carbon tetrachloride. So these are some solvents which we are using to prepare non-aqueous solution. We are replacing water with these different solvents and calling that solution what, as a non-aqueous solution. Okay, so do not get confused, do not get panic also. These are some benzene, alcohol, carbon tetrachloride. These are some organic solvent. I'll write the word here for your understanding. These are organic solvents. Okay, majorly made up of hydrocarbons. Okay, we are going to understand, we are going to learn about organic chemistry. There we are going to meet with these all different chemicals which we are using as a as a solvent to make what? Non-aqueous solution. Okay. Yes. So solvent other than water. So these are some more examples, or their chemical formula. We are having benzene there, ethyl alcohol is there, CS2 is there, CSCl3. So these are some organic solvent to make non-aqueous solution. Okay. Example, bromine in ClCl3, iodine in alcohol. These are non-aqueous solutions. See, this is a hydrocarbon, definitely not a water. This is also a hydrocarbon, not a water. Okay, but these are acting as a what? Solvents. They are solvents. Do we see water molecule here? No. That's why we say it's non-aqueous solution. What do we call it as? Non-aqueous solution. Okay, clear? Is there any doubt? Is there any confusion? Okay. So students, that was all like about the classification or types of solution which is based on the solvent which we are using. I'll just revise that once again. If anyone has any problem, try to understand, like, so that his or her problem will get away. Just a minute. So yes, we have started with this brand new concept called as solution. In chemistry, how solution gets formed? When two components are getting added with each other, such as what? Solvent and solute. Solvent and solute. These are two components. Okay, they are getting added with each other to give you what? Solution. Alright. So example which we have taken: sugar in water, salt in water, iodine in alcohol. Okay, so these are few examples of solution. Then we moved and we tried to understand the terms, the components, such as what? Solvent and solute, right? So the component which dissolves the other component is what? A solvent. Solvent usually present in larger quantity, as you all can see from this diagram. So this is how large this water. Okay, so to make salt solution, we have taken solvent which is larger, or more in quantity than the solute. This is what your solute is, which is lesser in quantity. Correct. Moving ahead, solute, which is what dissolves in solvent. It dissolves in solvent, right? And it is usually present in lesser quantity. Alright. Is there any doubt? Is there any confusion? And solute can be anything. It can be solid, liquid, gas, anything. Okay. Moving ahead now, based on the solvent which we have used, we have two different categories. First is what? Aqueous solution, where we have used water as a solvent. Correct. And that's why, and like, try to understand, try to remember this point also. Most of the substances are soluble in water, and that's why we called water as a universal solvent. Correct. Then we are having next type is what? Non-aqueous solution. Whenever we are using solvent other than water, this becomes your non-aqueous solution. And these are few examples, such as benzene, alcohol, carbon tetrachloride, etc. Is there any doubt? Is there any confusion? Alright student, that was all about the session today. Soon we are going to learn about different types of solution in our next class. Till then, take care.